Okay, I want to go ahead and review the bridge problem that we did yesterday. So here we are. This is a picture of a bridge, and it says a bridge is 100 meters long. So that's from the start here to the end. And it says every 5 seconds you walk half of the way remaining across the bridge. Now, part A is how long to get at least 99% of the way to the other side. So let's see what's going on here with this. So after 5 seconds, you walk halfway across the bridge. Well, the bridge is 100 meters long, and half of 100 meters is 50 meters. You can see that distance right here of 1/2. So you walked 1/2 from the start of the bridge to the end of the bridge in 5 seconds. This means that the amount remaining for you to walk, you started here and you're trying to get to here, you walked halfway right to here from left to right, and you have half the bridge remaining to walk. So the amount remaining to walk is 1/2 the total distance. Now, after another 5 seconds, for a total of 10 seconds of the whole trip, so another 5-second passes, you walk half the distance remaining across the bridge. So how much distance is remaining? 1/2. You walk half the distance remaining. Half of a half is a fourth. 1/2 times a half is 1/4. So that next 5 seconds, you just walk an additional 1/4 of the way across the bridge. That leaves you another 1/4 that you'll have to walk across the bridge. So down here, I show this, that you walked an additional 1/4 of the way across the bridge. 1/4 of the 100 meters is 25 meters. So your total distance now after 10 seconds is 50 meters from the original 5 seconds, 25 meters from this 5 seconds. So you've walked a total of 50 plus 25 or 75 meters. Your total fractional distance across the bridge is you went 1/2 the distance across the bridge in 5 seconds, and then you went 1/2 of that 1/2 remaining, which is 1/4 of the distance in another 5 seconds. When you add 1/2 plus 1/4, get a common denominator. This is 1/2 is 2/4, and 2/4 and 1/4 is 3/4. So now after 10 seconds, you walk 3/4 of the way across the bridge. The amount of distance remaining in terms of a fractional distance is 1/4. You've covered 3/4, and that whole distance, one whole distance minus 3/4, 1 minus 3/4 is 1/4 of the distance left. So at this point, you're right here, okay? So you were just drawing it. You started right here at this point. Here you are at this point, ready to walk across the bridge. Then in 5 seconds, you made it to this point. Here's 5 seconds went by, and you made it 1/2. Now, the next 5 seconds, you walk half of the distance remaining. The distance is 1/2, and half of a half is 1/4. So in another 5 seconds, you made it right to this point, walking across the bridge. Here was 5 seconds. And here was 5 seconds, right here. And that gives you a total of 3/4 of the distance. 1/4 is left. Now, in this next 5 seconds, you walk half the distance remaining. Half of this 1/4 remaining, half of a fourth is an eighth. So in another 5 seconds, you only make it this far, right here. Okay, and we'll show that right down here. So after 15 seconds, you walk half the distance remaining. Half of that fourth is an eighth. So you walked an additional 1/8 of the way across the bridge. 1/8 of 100 meters is 12.5 meters. So your total distance now is the 75 meters that you already walked plus another 12.5 meters takes you up to 87.5 meters. Or your total fractional distance across the bridge is 3/4 times an eighth. And actually that should be 3/4 plus an eighth, because you already walked 3/4 of the way across the bridge, plus you walked an additional 1/8 across the bridge. That gives you a total distance across the bridge of 7/8 the way across the bridge. So let's do one more time on this half the distance remaining. So now you're 7/8 the way across the bridge. And you can see you're right here, 7/8 across. Total distance, 1/2 plus a fourth makes 3/4 plus the eighth makes 7/8. So now the distance remaining, since you've gone 7/8 away across the bridge, the distance remaining is just 1/8. So you're going to walk half that distance. Half of 1/8 is 1/16. So here, after another 5 seconds, you only make it this much farther. You're right here, an additional 1/16, and we'll get that total distance down here. So after 20 seconds, you walked half of the distance remaining. The distance remaining is 1/8, and half of that 1/8 is 1/16. You walked an additional 1/16 of the way across the bridge. And in terms of meters, 1/16 of 100 meters is 6.25 meters. So your total distance now after 20 seconds is at 87.5 that you already traveled right here, plus the 6.25, giving you a total distance of 93.75 meters. Your total fractional distance across the bridge is the 7/8 that you already traveled, plus the additional 16th, which puts you up to 15/16 across the bridge, because 7/8 is the same as 14/16, plus another 16th gives you 15/16 the way across the bridge. So let's make a table of what we know so far. In 5 seconds, that's the first hit, you went 1/2 the distance across the bridge. So your total distance across the bridge is 1/2. The distance in meters, since it was a 100-meter bridge, half of that was 50 meters, and your total distance in meters was 50. And another 5 seconds for a total of 10 seconds. So the next 5 seconds is going by, and you walked half the distance remaining. So you added another 1/4. The additional distance that you walked was 1/4. Adding the 1/4 to the 1/2, you get to a 3/4 total distance across. So 1/4 of the 100 meters is 25 meters, and the total distance that you cross the bridge in meters is 75 meters. So you can see a pattern here. The next 5 seconds, you walk half the distance remaining. Half of 1/4 is 1/8. So you went an additional 1/8 of the way across the bridge. Your total distance now, 1/8 plus the 3/4 is 7/8. So you now are 7/8 of the way across the bridge. In terms of meters, half of that 25 meters is 12.5 meters. So your total distance now is this 12.5 meters plus the 75 meters. So that gives you a total of 87.5. And the last thing we did was take half of that distance remaining. So half of the 1/8 remaining is 1/16. Add the 1/16 on, take the 1/16 and add it on to the 7/8, and you get 15/16 now is your total distance across the bridge. So you haven't made it all the way across, but you see that you're getting closer and closer to making it all the way across. You're at 15/16. So in terms of additional distance in meters, half of that 12.5 meters is 6.25 meters. If you take that 6.25 meters that you went extra this time in this 5 seconds and add it on to the 87.5 meters, you get 93.75 meters. So to continue this out, the next 5 seconds, you would cover half the distance remaining. Well, we can see we covered 15/16 of the bridge. The distance remaining is really one whole distance across the bridge minus that 15/16. In other words, you only have 1/16 left to go across the bridge. And half of that distance, half of that distance is 1/32. So you have 1/32 of the way left to go across that bridge. Here, I'll do this. Let me hit enter so you can see it. So 1/15 minus 15/16 gave me the 1/16 remaining. And we always walk halfway across the bridge. That's what the original problem said, halfway across the remaining part of that bridge. And half of that 1/16 is 1/32. So now you're just traveling 1/32 across the bridge. Okay, that's where these came from. Where did the 1/4 come from? The 1/4 came from the idea that the person went 1/2 of, which means times, the 1/2 of the distance that he has remaining. Okay, where did the 1/2 the distance remaining come from? Well, that came from the idea that it's one whole distance across, subtract off the distance that they've already traveled, and you get 1/2 the distance left. And 1/2 of the 1/2 is 1/4. That's how we get the 1/8 here. We got the 1/8 by saying, geez, we already covered 3/4 of the distance, okay? And 1 minus 3/4 is 1/4 of the distance remaining. And now he travels half of that, and half of the 1/4 is 1/8. So he has 1/8 that he'll walk additionally. Okay, so that's how these are gotten, but you can see the pattern very easily here. It goes 1/2, 1/4, 1/8, 1/16, then what? 1/32. Then you just add these on. If you take the 1/4 and add it to a half, you get 3/4 the distance. 1/8 plus 3/4, 7/8 the distance. 1/16 plus 7/8, 15/16 of the distance, and 1/32 plus 15/16. Well, if you work that out, 1/32 plus 15/16. Well, you have to get a common denominator, and that would be 1/32 plus 30 seconds, because 15/16 is the same as 30 seconds. And when you add these, you get 31 30-seconds. So you can see a pattern here with these. We talked about that on the previous video from the previous week, but do you see how the numerator is always one less than the denominator? See, this goes up powers of 2, 2, 4, 8, 16, 32, and the numerator is always one less. One less than 2 is 1. 1 less than 4 is 3. 1 less than 8 is 7. 1 less than 16 is 15. 1 less than 32 is 31 30-seconds. And that's what you get when you add those two fractions together. So you're going to end up fractions that look like this. You know, next one might be 63 64ths. And then this distance, this added distance, is only 1/32 of 100 meters. Or in other words, it's half of this distance right here. Half of that 6.25 is 3.125. You can do that on a calculator. Then add that on to this 93.75, and that will get you what your total distance is at this point. So using this table and using what this lesson was about, this idea of fractional distance going across, which is good practice with fractions, good ideas that lead on to other topics in math, such as limits, we can answer these questions. So how long does it take to get to the other side? Well, think about these fractions here a second. And you know, when you get to the other side, you have to cover one whole distance. And you can see that all these fractions are less than 1. And in fact, will it ever equal 1? So maybe a better question than how long does it take to get to the other side, maybe the question should be, will you ever make it to the other side? I don't know why this is coming up here like that, but let's keep on going down here. What distance across the bridge are you approaching is part C here. What distance across the bridge are you approaching? You're getting closer and closer to what? Making it all the way across the bridge, 100% across the bridge. And we just modeled this situation here with math, with the fractions getting closer and closer. So let's take a look at some other fractions here real quick and see what we can determine they're getting close to. So here's a pattern of, it's just a sequence. We're not adding these, it's just a sequence of fractions. And these are actually the values that were from this problem, like 1/2, 1/4, 1/8. So if you look at these numbers here, 1/2, 1/4, 1/8, 1/16, and so on, the question is what is the value of this fraction as the denominator gets larger and larger? So you can see what the pattern is here, and what is the value of this? Like 1/2, we know that's 0.5. 1/4 is 0.25. 1/8 is 0.125, and so on. So what is this getting close to? Okay, so as you go farther and farther in this pattern, that you can, maybe the easiest way is to look at it in terms of decimals. What is that decimal value getting close to? Now part E is another one where we're looking at what is this approaching? Okay, so we see 1/2, 2/3, 3/4, 4/5, and some of these are ones that were up in that pattern there when we added them together. So like here's a 3/4, here's a 7/8, but the pattern comes from just increasing the denominator by 1 and increasing the numerator by 1. But it always started that the numerator is 1 less than the denominator. See that 1 is 1 less than 2, 2 is 1 less than 3, 3 is 1 less than 4. So other fractions that are going to show up here like 8/9, 9/10, and so on. Well, you can switch these over to decimals and see what value it's getting closer and closer to. And this is an idea, a major topic in math, which is called limits, getting closer and closer to something. So getting closer and closer to the way across that bridge. See, we're going half the distance remaining. And while, we don't walk this way in real life, this brings up a lot of good concepts in math that have been around for, over 2,000 years. And that's one of the videos I put up was called Zeno's Paradox. And that's the idea of it right there. So I'll stop this video right here, and hopefully this will help you with the problems on the homework that are based on this.